Assalamu alaikum wa rahmatullah. Hello, ladies and gentlemen. It's Mohamed Tohami Abou from Libya. I am a PhD student, Civil Engineering Department. It's my pleasure to be one of the presenters of IBUDAX 21 conference. On behalf of my author's friends, I would present today our work, which is a comprehensive study on the dynamic performance of rubberized concrete brick walls subjected to cyclic loading. I will start with a brief background of the study, followed by the literature review, and finally a brief conclusion. Starting with the background of the study, there are different stages of tire shading used in the industry, and these types faced many challenges to study and analyze their properties. As you can see in the table, the ultimate strength dropped as the proportion of chrome rubber increased. As a result, when used chrome rubber in replacement with other materials in cement-based composites, the required minimum strength must to be addressed. The effect of chrome rubber on compressive strength of salt cement bricks as coarse and fine rubber replacement. The comprehensive strength of manufactured salt cement bricks as a function of the replacement percentage of conventional aggregates and cement content is depicted in the figures here. As expected, the compressive strength increases by increase the cement content as known. And as you can see in graph A and graph B, in fine rubber replacement, the acceptable effect of increasing cement content was more significant than in coarse rubber replacement. Graph A for the coarse rubber replacement and graph B for fine rubber replacement. And for the characteristics of masonry brick, it can be observed that the stiffness of walls decreased proportionally with the increase in rubber content, indicating high flexibility. Moreover, the effect of coarse rubber was more detrimental of the stiffness than the effect of fine rubber. On the one hand, that toughness was slightly increased by increasing the cement content. Here, as we can see in the first part, the cement content is 250 and the second part 350. On the other hand, the utilization of rubber significantly enhanced the toughness of walls, regardless of rubber size. This means that the rubberized wall have a significant capability in sustaining post-failure loads and absorbing large energy for fracture than an rubberized concrete. Bracing system to improve the dynamic behavior of the structure. In fact, bracing system must be connected to the existing buildings at each story by horizontal steel trusses mechanically anchored to the reinforced concrete members. Remarkably, the reliability of the retrofitting technique depends on the efficiency of such connections, which must be designed carefully, extensively embanked, because it impacts the beauty of the building. And for this system, actually, it's showing many good results, let's say many positive results for enhancing the earthquake resistance, but at the same time have many backdraws. Okay, let's talk about the literature review of this study. In fact, for the last some period, the construction industry is taking up the challenges to increase the sustainability in the production activity. How? By researching for more environmentally friendly raw material or by the use of solid waste material as an aggregate in concrete. One of the possible solution for the use of waste from rubber is to incorporate it into concrete brick to replace some of the natural aggregates. The process is also economically viable as some of the costly natural aggregate can be saved. This is the big advantage of use waste tires or chrome rubber in structure elements, which is can keep the raw material and enhance or more usage for more utilization of the waste material. The properties of chrome rubber as an aggregate replacement are investigated in this work to determine their effect on structure behavior under seismic stresses. The goal of this study is to provide a theoretical framework for using chrome rubber as an extra material in concrete brick walls to improve the seismic resistance of the building. When we talk about the seismic resistance of the building, we can say that according to studies, masonry brick walls can be extremely fragile. Furthermore, the inclusion of chrome rubber in the concrete mix is accepted to enhance the masonry brick walls ductility. So, utilization of chrome rubber can improve or enhance the ductility of brick wall system. Investigation of the properties of this concrete production and how the inclusion of combined chrome rubber and metakaolin affect such properties, as well as optimization between them, need further exploration. Other researchers reported no increase in energy dissipation as a result of rubber replacement, and this is what makes the previous studies are unstable, let's say, because actually they did good job. But some researchers say that you can replace a fine aggregate, you can replace a coarse aggregate. Some researchers say that no, you cannot replace the coarse aggregate because you will not get a good compressive strength. That's why more studies, more experimental works need to investigate to get the optimum mix of the design of the mixtures. This paper actually aims to provide a literature review on the dynamic performance of rubberized concrete bricks walls subjected to cyclic loading. To sum up, the potential use of chrome rubber in concrete brick. Chrome rubber has a strong potential to be utilized as a substitute material in concrete brick to increase the ductility, because this is the important parameters for using the chrome rubber. Will not focus about the negative side of using or utilization chrome rubber, which is decrease the compressive strength. So we can get that point from previous studies, which is increasing the ductility of brick walls due to their capacity to undergo substantial elastic deformation before they collapse. Further researches, as we mentioned before, further researchers are needed to investigate the dynamic properties of brick walls by applying the cyclic loading on the wall, structure wall, or a concrete brick wall system. And that's it, and thank you very much for your attention.